We had 8 questions for homework last night. It was worksheet number 2, our impulse worksheet. We want to go over 3 of those questions here today, starting with number 6. Number 6 says, a 1 kilogram ball traveling towards a soccer player at a velocity of 5 meters per second rebounds off the soccer player's foot at a velocity of 8.5 meters per second. Time of contact between the ball and the player's foot was 2 times 10 negative 2. What's the magnitude of the force that was applied on the ball? I just picked up a red pen. I don't know if anybody noticed that. When I pick up a red pen, that's because I want to draw attention to something. What is it that I want to draw attention to here? Okay, not my givens, not general stuff like that, but things that can lead to a silly mistake. What could lead to a silly mistake there? Yeah, it's towards me then away. So the direction switches, right? It doesn't really matter which one I make positive, which one I make negative here. It's not as cut and dry as north and south is. Okay, but one of them is going to be positive, one of them is going to be negative. I made this one negative, and I made this one positive. But you could have easily reversed that and made that first one positive and the second one negative. All right, what is it that I'm going to do to solve this problem? What concept am I going to use in this question? I've only learned a couple. It's impulse. How do you know, George, that it's impulse? What tells us, besides the fact that it says impulse at the top of the worksheet, besides that? Yeah? Yes, good. There's a force and there's a time. It doesn't matter if I'm looking for force and I've got time. It doesn't matter if I've got force and I'm looking for time. It doesn't matter if I have both and I'm looking for something else. If I see a force and a time in the same question, I'm going to do impulse. Just like when the question asks for impulse or asks you for the gain of momentum. Let's write down some givens here now. We're going to say the ball is 1.00 kilograms. Let's say the initial velocity with the way that I define direction is negative 5 meters per second. Now we're going to say VF is positive 8.00 meters per second. Again, those could have been reversed as long as one is positive, one is negative. The time interval here is 2 times 10 to the negative 2. And we're looking for the force. Now, we know that impulse is equal to F times T is equal to M times delta V. 3 parts, but I only ever need to use 2 parts of it here. I'm going to erase the part that doesn't appear on my data sheet. Just use this. Megan? Oh, 8.5. Thank you. Yeah, that should be 8.5 meters per second. Thank you. Doesn't change the way we do the question, but it does change our answer, obviously. Let's rearrange this to solve for F here. We get M times delta V over delta T. 1 kilogram times, be careful on this one, VF minus VI. VF is 8.50 minus 5.00 meters per second, right? Right? If you do this, if you do that, then the answer you're going to get is 175. How many people got 175? You knew what you were doing, except you missed the fact that one of them is positive and one of them is negative. Does that make sense? You missed the direction thing. You made that silly mistake that a lot of people make. We just want to hopefully get that out of our system on worksheets and so on before we have a quiz or a test. Let's divide that by the time interval now, which is 2 times 10 to the negative 2. I'm going to pull the calculator out and go through this with you on this one. We're going to say it's 1 times bracket 8.5 minus negative 5. And now let's divide that by 2 times 10 to the negative 3. Guys, listen, when you're doing an exponent like this is what I see people do a lot. Okay, don't do this. Please do not do this. 2 times 10 to the negative 2. Don't do that, especially when your exponent is a denominator, when it's on the bottom. Here's the easy way to do it, in the way that your calculator assumes that you're doing it. You do it that way, when it's on the bottom, you're going to get the wrong answer because your calculator assumes the wrong order of operations. You do it this way, you're good. Divide that by 2, and then go second function, EE. That's 2 times 10 to the negative 2. And your calculator knows what you mean when you put that in there like that. Is that okay? Especially when it's on the bottom. You know what? When it's a numerator, you get away with the other way. But when it's on the bottom, you don't get away with that unless you're good with brackets. We end up getting 675 for, which is what we expected. It's positive because look, if the final velocity is away from me, positive, then the force must have been away from me, positive. Okay, new request to do question number 5, so we'll take a look at that one, and then we'll move on to 7 and 8. So it says a 1,500 kilogram car traveling at 80 kilometers per hour comes to a screeching halt in a time of 4 seconds. Calculate the force of friction experienced by the car. Red pen? We should always be thinking about the red pen, right? Even if sometimes we get a question where you don't actually need to use it, we should always be thinking about, is there anything that could lead to a silly mistake? In this case, there is. It's the kilometers per hour here. There is something else that I don't think I want to circle in red, but there is a little kind of read between the lines thing here. By the way, 22.222, that's 80 divided by 3.6. Anybody kind of catch the read between the lines thing? There's something else that I have here. Yep. Yeah, it comes to a screeching halt, so VF is equal to 0 meters per second. So looking for force, I'm going to say F times T is equal to M times delta V. The impulse equation as it appears on my data sheet. Rearrange to solve for F again, just like we did in the last question, number 6. M is 1,500 times delta V is VF minus VI 0 minus 22.22. And you do the math there, you should get negative 8.33 times 10 to the 2. If you can't get that answer, just let me know and I'll go through it with you. Anybody spot something when we get to this point right here? F is equal to M times delta V over delta T. What's that the same as? F equals M times delta V over delta T. What's delta V over delta T? Yeah, if I rearrange that, but I'm looking specifically at this. What's delta V over delta T? It's acceleration, it's A, right? So this is the same thing as saying F is equal to M times A. F equals MA, right? Go figure. It's the first thing we did when we introduced impulse was drew the connection between Newton's second law, F equals MA, and impulse. Ft is equal to M times delta V. Question? 10 to the 3. 10 to the 3. Oh, yeah, that's what I get to. Yeah. Sorry, just a trick. You passed. 2.67 times 10 to the 3, yeah. Yeah, number 4. All right, let's take a look at number 7 now. Okay, 7 says a 1.5 kilogram rock falls from rest from the top of a 10-meter high building and strikes the ground below. What's the impulse experienced by the rock during its fall? Clearly an impulse question because we're asked for impulse. We could also be asked for the change in momentum. It would be the exact same answer. We have a rock that has a mass of 1.5 kilograms, and it starts at rest. VI is 0 meters per second. It falls 10 meters, so we're going to say my displacement is negative 10.0 meters, and we're looking for the impulse during that fall. I could say F times T, or I can say M times delta V. I think that's what I want to do there. M times delta V. I don't know what delta V is, but I can say for this one, VF squared is equal to VI squared plus 2AD. VI is 0. VF is 2 times neg 9.81 times neg 10. 14.00714. Is that right? What have I just found? What have I just solved for? Be careful to choose your words wisely here. Indiana Jones and the Last Crusade. Choose wisely. The final speed. The final speed. Not the final velocity, which is what I want, right? The final velocity is not 14, but negative 14. So we're going to say it's 1.5 times negative 14.00714 minus 0, because the initial is 0. When we do the math there, it works out to be negative 21.0 Newton seconds. We gained momentum in the downward direction, the negative direction, which means that we have a downward impulse or a negative impulse. Number 8 looks a lot the same setup to the question. This time, though, we want to find the force of the ground acting on this rock when it hits. So we're not analyzing the fall this time like we were in question 7. This time we're analyzing the collision itself. We have a mass of 1.5 kilograms. Tell me what VI is for the collision? No. No, what is it? Yeah. How is it that we just said 14 was VF, but now we're saying it's VI? Yeah, Don? Yeah. Like we got two separate problems here, right? There's the fall, and then there's the collision. At the end of the fall, it's moving at 14. Well, that's the beginning of the collision, right? So it's the final speed of the first problem. It's the initial speed of the second problem. Can you tell me what the final velocity is of the second problem? The final velocity of the collision is 0. And the time interval here is 0.350 seconds. Looking for force. What do we got here? M is 1.50. Delta V over delta T is VF minus VI. Be careful here. 0 minus negative 14.00714. I'm going to pull the calculator for this one as well here. Make sure we can all do it. Let's say 1.5 times bracket 0 minus negative 14.00714. And divide that by 0.35. We get an answer that's 60, positive 60. Why is that positive? Why should it be positive? If down is negative, what way do you got to apply a force on this rock to stop it? Up. If you apply another force downwards, what happens to this rock? It speeds up at a rate greater than 9.81. Doesn't stop. So our force is positive 60.